Okay, great. So I think, I mean, 2024 has really been an actually pretty exciting year for Ethereum in a lot of ways, right? And, sometimes, like, you go around, you see people blabbing on the internet, and, sometimes, like, you see it's definitely easy to get depressed, but then it's easy to get depressed on the internet about anything. But for me, it's like, one of the reasons why one of the reasons why I always just appreciate coming to these and just talking to people in person is that you just always see like the sheer number of positive things that are happening in the ecosystem from every single angle, right? From the application angle, from the layer one angle, from the core infrastructure angle, like pretty much everything has actually been, I think, vastly improving for the Ethereum and for all of the underlying infrastructure in the last 2 years, right? And for me, these two charts basically summarize the core of what's going on, right? So I often tell a story of how in 2021, I was visiting Argentina for the first time. And of course, Argentina, it has the whole tragic economic situation with the currency depreciating, I think average of 30% per year for the last century or something crazy like that. And the challenge, and so as a result of this, there's a lot of people who are crypto users. And so I walked around and I actually used Ethereum to pay for things twice. And actually, at one point, I was walking around on Christmas Day when almost everything in Buenos Aires is closed. And eventually, I found the first coffee shop that was open. The owner immediately recognized me and invited me and my group of friends in. Now, I paid, and I paid with an Ethereum wallet. Now, the transaction fee for that cost me, I think, about $5. And what's worse is that the transaction took about 5 minutes to get accepted, right? Now, actually, it took long enough to get accepted that halfway through, I got frustrated and I also made a payment at the same time on Arbitrum. And so I think like the guy actually got like both the L1 payment and the Arbitrum payment. But the point is that like the UX and the fees and like every step of it had a problem. And so what is the result? What was the result of this, right? The result of this was that even though a huge number of Argentinians were crypto users, they were not blockchain users. And to me, this is a problem, right? I mean, to me, if we get to a world where we have 2 billion crypto users, but they're all crypto users that are using USDC in some account on a centralized exchange or in some wallet where their account is controlled by their Google account, then like actually we failed, right? And so to me, I think we do need to actually try to do something better than that. Now, what's interesting is that in the 3 years since then, both of those two big problems I've mentioned are basically gone. So on the chart here on the left, we have fees on layer 2s. At the start of the year, transaction on a layer 2 cost somewhere between 20 and 50 cents. And 20 and 50 cents is much better than what Ethereum L1 fees were back in 2021, which is like often $5. Actually, the most I've ever paid on a L1 transaction fee was $800. This was admittedly, I'm actually for a privacy-preserving transaction through Tornado Cash. Like basically, I wanted to like set up one of my one of the like multi-sig guardians for a wallet without the world like all knowing like exactly like which address and being able to trace which person it is. But like for a privacy-preserving transaction cost like I think something like $1 million gas, and so obviously it costs $800. But like even a simple ERC transfer back then would have cost tens of dollars and nothing worked, right? And so transaction fees of 20 to 50 cents are much better than paying tens and hundreds of dollars. But it's still not enough, right? So who here remembers back in the like Bitcoin 2011 and 2013 days when people were trying to like really excitedly get Bitcoin adopted just as a means of payment. And the big thing that people were excitedly saying about why you as a merchant should use Bitcoin is that Bitcoin has no fees, right? PayPal charges 29 cents plus like 3% a transaction, even more if it's international. Western Union charges like $5. Bitcoin, less than 0.01 cents. Moving money far better. Who here remembers this? Okay, go raise your hand. Who remembers this? Come on. It's OG Bitcoin love. Okay, so basically what happened, and the reason why the original crypto payments dream basically failed the first round, is that crypto itself stopped actually having that advantage. And the 20 to 50 cent range is already the range that like PayPal charges you for an average transaction. And so if you go from 20 to 50 cents, then where do we go to after EIP 4844, which introduced blobs in March this year? We went to an average of less than 1 cent, right? So 1 cent is, or actually I think recently 0.2 cents even, right? That's a very powerful and very massive difference. And I think this is true in a couple of ways, right? First of all, less than 1 cent is the level at which, as a user, you don't care how much you're paying, right? It's like, people sometimes complain about paying for gas, but like who here drives a car? I mean, I actually don't, but I like observe people driving cars. So when you drive a car, right, like you have a gas tank, and every time you like accelerate and decelerate and like turn left and you turn right, you're actually like spending some amount of gas, right? And like you're like literally spending like probably some fraction of a cent on each turn and each acceleration. But nobody like actually thinks about or notices this, right? Now, why is this possible? Well, because gas actually costs that little, right? If we were in a world where gas was so much more expensive that like literally stopping at an intersection and then continuing is something that would cost you like an entire 25 cents, people would just run red lights everywhere, right? So the difference between like 20 cents and less than 1 cent is like massive from a perspective of who would be willing to participate. It's massive from a UX perspective. It's massive from a perspective of making this Ethereum accessible to the next million. It's like a really big deal everywhere, right? So that is transaction time, or sorry, transaction cost. We could also talk about transaction time, right? So Bitcoin, 10-minute block time. Of course, 10 minutes is an average. Sometimes you have to wait an hour. Ethereum before EIP 1559, 13-second block time, but in reality, if you got unlucky with the base fee, then you would often have to wait sometimes 5 minutes, sometimes 20 minutes. That's what happened to me in Argentina. Now, post EIP 1559, transactions generally pretty reliably get included in a couple of blocks. And then finally, today we also have L2s, and some of those L2s have pre-confirmations. And so we have this like nice steady progression where the amount that you have to wait has gone down from tens of minutes all the way down to potentially under 1 second, right? And so we basically have like better than credit card competitive UX, right? If you think about like paying with a credit card, like you pay, you tap, and then like on the terminal, the like, you see the circle like spinning around for a while, right? And like actually the amount of time you have to wait is like basically 1 Ethereum slot, right? And so even on L1, I think we're like pretty competitive to credit cards already. And then on L2, like much better, right? So basically it's a lot of really key problems this year have actually been solved. And for a lot of applications, like the Ethereum ecosystem is actually feature competitive to build a lot of mainstream applications. And like we've seen a bunch, right? So payments and stablecoins continuing to take off, continuing to improve. Even people using ETH for payments, people doing all kinds of payments, continuing to quietly happen. Prediction markets, one of the reasons I love this example is that it's actually gotten attention from people who are normally even far away from the crypto space. Like even the kinds of people who tends to casually say, oh, crypto is a scam, crypto is useless, even they are then are also retweeting screenshots of Polymarket, right? Like that's the ultimate victory. So then decentralized social, forecasters like actually bringing in a sizable amount of non-crypto people. then obviously, yeah, you get into games, and then you get into like various versions of wrapped DeFi that are increasingly actually targeting like more mainstream audiences. So lots of things are succeeding that did not succeed before, including lots of on-chain things, right? And not just things that try to like completely hide the blockchain from the user and like act like it's this like shameful thing you're supposed to like put somewhere in the back corner of the kitchen, right? So I think we're seeing a lot of success, right? And so question is, well, what do we need to do to actually take the next step? So the way that I think about this question is I first think about the goal, right? And the way that I think about the goal is like this, right? I think there's basically historically been these two types of software that we've seen. One type of software basically sacrifices decentralization for practicality, right? And this is like most commercial software. It's like most software that most people use by default. And it gives a good and improving user experience, but it sacrifices decentralization, and there's lots of important edge cases where it really, really doesn't serve the user well as a result. Now, on the other side, you have applications that sacrifice practicality for decentralization. And this happens on two dimensions, right? The first dimension is you have applications where just the technical properties of the application end up really sucking because they take like lots of hard trade-offs to ensure that everything is fully decentralized, fully serverless, and so on. And the other dimension is like something much simpler, which is basically that decentralized things and things that treat their users with respect are harder to monetize, and as a result, you're not able to like push the features and the UX up to the same standard of quality. There is this very long tradition of pre-blockchain decentralized software, even pre-blockchain open source, that totally falls into the second trap, and there's lots and lots of software, I think including, unfortunately, lots of applications in the crypto space that fall into the first trap. I think as an ecosystem, we should reject both of those traps, and we should even reject the trap that we need to like bifurcate and create like the niche nerd ecosystem that's decentralized, and then the normie ecosystem where like actually everything has to like go through trusting like Google and AWS for everything, and we need to like actually do the hard thing and take both. And I think there's lots of technologies that we have available that mean that we actually can do this. So we'll talk about practicality first, right? So what are some examples of practicality that the ecosystem still needs, right? So one of them is more scale. So today, transaction fees are less than 1 cent, but today the amount of blobs that are being used by layer 2s is basically exactly at the target. And because it's exactly at the target, that basically means that it's not able to actually scale more without increasing costs for users and pricing out certain low-level transactions. Now, that's not entirely true because actually, as I'll talk, there's a lot of unclaimed ways for L2s to use data more efficiently. But it's like roughly, we haven't won permanently, right? And so we still need to improve scale, and especially improve scale at layer 2. Shorter confirmation times. So 12-second slots are competitive with credit cards, but credit cards suck, and we should not be competitive with the thing that sucks. We should be competitive with the centralized thing that's good. And so we want like shorter confirmation times, realistically, shorter than 2 seconds for important operations to happen. Cross layer 2 interoperability. So today, bouncing between different layer 2s feels like you're bouncing between different blockchains. It should not. And then user account security. And so I'll still talk about some aspects of this. And I think like this example is one of those things that's like really at the core of being decentralization friendly and next billion friendly at the same time. And so we'll talk about that too. So let's talk about more scale. So for more scale, this is approximately on the left the plan for what L1 aims to do over the next couple of years. So of course, everyone's probably heard Justin has said like 2029 for the completion of the full beam chain. I think it's like really important to clarify 2029 is like the intended date for when everything finishes. We're gonna get the scale much sooner, right? So Basically, the next step is to implement PeerDAS, and PeerDAS will get us from about 3 to 4 kilobytes of data per slot to about 1 to 4 megabytes per slot, and then eventually full DAS, which will get us to 16 megabytes per slot. And on the other side, there are improvements that layer 2s can make to implement data compression, where if you take all of the ideal technologies and stack them together, you can go down from about 180 bytes per transaction, potentially all the way to 23 bytes per transaction. So this is also a 7x. And I think most of this so far has been relatively unclaimed. And I think one of the reasons why actually is because everyone has been using ECDSA signatures, and an ECDSA signature is 65 bytes. And so if you do like everything else well, but then you still have the ECDSA signature, then your 23 bytes goes up to like 85 bytes, and like instead of a 0.9 order of magnitude improvement, you have like a 0.3 order of magnitude improvement, and that's like not very interesting, right? And so I think aggregation and really like merging signatures together is one of those key things that we actually have to do, and then otherwise like a lot of compression techniques. If you stack these two things together using these numbers, then you get about 60,000 transactions per second on the layer 2 ecosystem. There are ways to go even beyond that securely, using technologies like Plasma, using hybrid roll-up Plasma techniques, things like what IntMax is doing. So actually, we can go even further than this, right? But more scale is one of those things that's really important. Shorter confirmation times, right? So I see basically two classes of techniques that can do this in the short term. So one of them is L2's having sequencers, which they do already. Though one of the challenges, of course, is that today they're trusted sequencers. We need to make them provide like stronger trust guarantees. And the other strategy is based rollups plus L1 pre-confirmations, which is a space where there's actually a lot of work that's started already. Now, in the longer term, I think we'll be able to get the single slot finality and like also push the slot time down quite a bit, but that feels like relatively a more long-term thing. Pre-confirmations feel like a somewhat shorter-term thing, and so I think on L1 and on L2, we can keep reducing confirmation times by quite a bit. Cross L2 interoperability, right? So I think this is one of those problems that has like both a short term and a long term. And for me, the goal is basically that moving between the L2 ecosystem should not feel like you're moving between different planets. It should feel like you're on Ethereum. And so one of these examples is new address formats. So the address should just include which chain you're on. And if you take one of these addresses and you put them into a wallet and you click send, the wallet should just automatically interpret your send as a request to go through a cross L2 bridging protocol like ERC7683. Hello. And basically, you'll be like, like that protocol already, it can actually do optimism to Arbitrum, at least for relatively low value amounts, which basically means like non-millionaire amounts in like 2 seconds, right? So technology's there, it just needs to be like really deeply integrated in the UX. Longer term stuff, general purpose cross layer 2 messaging. So I think these like intent-based bridging protocols, I mean, they work for like very common assets that are very high volume. They work less well for rare assets, and they definitely don't work at all for NFTs. Because like, how do you even like front liquidity for an NFT? It's like, hey, I have Vitalik.eth, and that means you also have a copy of Vitalik.eth, and you use that to front my liquidity. Like, this doesn't make sense, right? So, like actually, like very well standardized cross L2 messaging. Also, potentially. Also more complex interops, so doing things like shared sequencing, which will make a lot of the financial operations happen even more effectively. So there are all of these things that actually can be done, and they're already starting to be worked on. So user account security. So the way that I think about user account security is like, in the crypto space, we've basically been like stuck in this like trap between two extremes, right? And so the two extremes are, on the one side, you have like, the maximalists who are like, you need self-custody, you need self-sovereignty, you need to hold your own private key, and then you write down your private key on a 12-word sheet of paper, and then you take that 12-word sheet of paper, and then you engrave it in titanium, and like make sure that it's fire resistant. Then you put that in a safe box, and the safe box can be like made out of tungsten, and then you take the tungsten, and then you like lock it up, and you push it like 19 feet underground. No, wait, sorry, we're not in the U.S. You push it 19 meters underground, and then and then it's going to be safe, right? And you have like people who like literally make blog posts that basically say that, right? And then what happens on the other side is you have a bunch of people who just say like, screw you, this sounds like a nerd hobby I don't even want to get into, or I'm afraid I'm going to even screw up. And they basically say, well, this stuff is annoying. Instead, I'm going to take all my coins and I'm going to put them into a trustworthy, centralized exchange that's run by trustworthy founders who are vegan and donate to effective altruism and who go on panels with Bill Clinton. Now, the challenge, of course, is that 2 years later, one of these founders might end up having financial relations with your assets, and of course, like basically your money ends up being gone, right? And so, I think we basically don't want either of these, right? And I think there is like actually a very strong roadmap to getting something that combines the benefits of both, that protects you from your own mistakes and that protects you from centralized bad actors. So those are practicality goals, right? So let's talk about decentralization goals. How do we achieve all of these things in a decentralized way? So the strategy for scale on L2 is data availability sampling, right? The basic idea is you have these blobs of data, and instead of downloading the entire blob, each node only needs to download a small portion of each blob, and the blobs are erasure coded, and there's math that happens in the background that basically ensures that even if up to half of the blob disappears, the other half of the blob can be used to recover the rest, right? And so, it's like one of those like Borg cubes from Star Trek, right? You can like damage anything up to like, I think in Star Trek it was like you can damage all the way up to 73% of the cube and it can heal itself, right? It's like exactly that sort of thing, but like for data, right? So data availability sampling, basically each client only needs to download and sample a small portion of the block, and there's a one-dimensional version of this that is doable short-term, and then there's a two-dimensional version of this that is doable relatively longer term. So this way we actually get a decentralized network, and like basically that has some of the properties of being a peer-to-peer network in the sense that if you think of how BitTorrent works, BitTorrent does not require every user to download every file. It's a highly distributed system. Different users store different files. So if we want to scale, we need to figure out how to do that same thing, but with consensus blockchain guarantees. Data availability sampling solves that exact problem. So that's one piece. Now, let's talk about shorter confirmation times, right? So I think there is a couple of strategies. So one is L2s with centralized sequencers, I think, are okay for some apps, right? So, I saw, like this event, there's like an entire gaming section, and lots of people are excited about gaming. So, okay, so who here has played World of Warcraft? Okay, it's like, the one game that I've like properly played, except for games that I like coded for myself when I was a teenager. So in World of Warcraft, you have this like latency bar, right? And the latency bar, when the latency is less than 300 mils, it's green. When it's between 300 mils and 600 mils, it's yellow. And when it's above 600 mils, it's red, right? Okay, so who here remembers like in World of Warcraft trying to like fight any kind of like actually hard monster, or even like doing PvP when the latency is like red, when it's above 600 mils, right? It like sucks, right? You die very easily. So the challenge, and like World of Warcraft itself, like explicitly tried to be casual friendly and like tried to make extreme low latency not matter, right? And so the challenge is, of course, that a decentralized system, I think, basically has no way to get less than 600 mils of latency and at the same time stay decentralized, right? It's like, okay, you can build up the crazy infra and you can do the math, like theoretically, one side of the world to the other side of the world, that's 20,000 kilometers, divide by speed of light, that's 67 mils. You need 3 rounds of consensus and then 200 mils. But that's like an incredibly like fragile efficiency maximizing approach that's like not at all appropriate for like an actually robust and decentralized blockchain, right? And like and the problem is that not only do you want to make decentralization possible, you also want to make sure decentralization is not overly economically penalized relative to like extreme optimality, right? And so we actually want pretty big safety factors. So decentralization is not going to offer the best experiences for everyone, and so I think for that reason, like layer 2s with centralized sequencers are okay for some applications. And then, of course, you have layer 2s with some decentralized sequencing. And then the other approach is layer 1 pre-confirmations, and that can be done in like a centralizing way, or it can be done right. And I know there's a lot of teams that really wants to do it right, and so this slide is, I think, taken from one of Justin's Ether Research posts. So that's one of the directions. And then the other direction is like actually like super optimizing the Ethereum consensus loop and basically trying to make the peer-to-peer as optimized and as unwasteful as possible. So I think we have both of those approaches. Cross L2 interoperability. So if you want to keep it decentralized, so I think for me, the way that I think about this is that for interoperability, it's like moving between cities, right? And like, if you're a country, then you're going to want to provide at least some specific method of moving between cities as a public service, right? You know, you have the cars, you have the private helicopters for like, you know, the Taylor Swifts of the world, or I forget, maybe she uses a plane. I'm like not too into this stuff. You know, for everyone, but then for everyone else, like there is a you know, highly robust subway and bus system, and at least it's always there, even if you can't afford the other thing, or even if the other thing like suddenly goes bankrupt on you, right? And so to me, like the equivalent of this is that the Ethereum ecosystem needs to have an always available, total decentralized, non-single party dependent protocol that people and applications will always be able to use in order to move assets from one L2 to another. And for me, like ERC 7683 satisfies that goal, right? And I think there are going to be specific situations where like individual tokens might be able to optimize on top of that. So like if you're using USDC, you trust USDC already, you might as well just let them like insta-bridge for you. If it, like individual layer 2 ecosystems might have like direct movement that's about as fast. So sometimes you can improve on it, but having the baseline is really valuable to me. So that's one. Light clients. So light clients, basically, yeah, you want to be able to actually verify what's going on L1 or on L2 in a mobile wallet or in a browser wallet without having to trust an RPC. And there is work that's being done by the Helios team, which is actually pretty close to actually letting us do this. Shared bridges, so this is technology that basically would allow a token to be stored in a structure that is owned by multiple L2s simultaneously. That makes it really easy to do batch transfers between them. And so in the far happy future where every L2 is a ZK rollup that's committing to Ethereum every slot, then you're going to be able to also do native, like liquidity provider free asset movement from one to the other in one single slot, which is probably the best that we can do. And then also for based rollups, we can do shared sequencing, right? So there's a lot of good things that we can do in terms of cross-L2 interoperability. Let's talk about account security. So this is one of those things where I think there actually is an opportunity to build something that works for new users and for experienced users at the same time, right? And the way that I think about this is I think about this with Guardians, right? So for your account, realistically, what you want is you want like a key on your device, and then that key alone can authorize low-risk operations, right? So with your crypto wallet, you should be able to like tap to pay $25, but you should not be able to tap to pay $25,000, right? That's the wrong like convenience risk trade-off. Then if you want to do more intensive operations, or if you want to recover your primary key, then like you have some collection of things. For a starting user, possibly one, but then ideally go up to some collection of several of them. And these guardians could be your own physical devices, so hardware wallets. This could include friends and family, so either their Ethereum addresses or things in this whole category that are owned by them. It could also include institutional guardians, which include specialized services, and the big unlock this year is ZK wrappers of existing services, right? So the way that I think about this is that for in the Unix philosophy, text is the universal interface for communication. In the Ethereum philosophy, an ETH address is the universal interface for authority. If you want to make something that is controlled by an email address, you use ZK email, and you can generate an Ethereum address, which you can only spend from if you control that Ethereum address. And thanks to email DKIM signatures plus zero knowledge proofs, you can actually do this. You can also make a similar wrapper around any kind of government digital ID. You can make a wrapper around passports. You can make a wrapper around with a TLS notary, any other Web2 service. And so basically, you can turn almost any existing root of trust into an institutional guardian, right? So there's a lot of interesting different alternatives here. Now, so the vision that I want to see, right, is so this is like a mock-up, right? Imagine a version of Gnosis Safe where you can basically set up your guardians, and then you have like a bunch of fields, and you can stick an email address in there, or you can stick an Ethereum address in there, or you can stick like a government ID number in there, or you can stick a Twitter account in there, and it just automatically, under the hood, converts each of those things into an Ethereum address, and it just generates you a multisig, which is like actually in the back end controlled by any one of these, right? And so how do I envision this being used by actual users? So imagine you're a new user, and you decide, hey, I'm tired of Twitter, I want to move to Farcaster. So what does Farcaster do already? What Farcaster does already is it actually sets up an in-app wallet for you, generates a private key. With that private key, you can sign things inside of Farcaster. Inside of Farcaster, in the Advanced tab, there is already an option to change your recovery address from Warpcast centralized recovery to any arbitrary recovery address of your choice. This is something that you can just already go and do. Now, basically, I think what we can do is like that, but for every application, right? If you're a new user just coming in, then you should not need to already have an Ethereum wallet to download your application. But if you do have an Ethereum wallet, you should be able to easily link any application to your Ethereum wallet, and it should have all of the benefits of like basically acting as part of your Ethereum profile, but at the same time, like you keep that separation, and potentially you even keep the link off chain, and you do things with zero knowledge proofs, and so you even have greater privacy than today, right? So, and then potentially a user would start off with the only guardian being either their email address or the service, and then over time, as they have more applications and as their like profile becomes more mature, they would be able to just like upgrade their security setup over time, and then make very easily just turn their account into a multisig with whatever participants they want. So I think basically we can create a framework in which new users get something that's very user-friendly for new users. Existing crypto users get things where they can just put in the same 12-word seed phrase that they're already comfortable with, and it becomes very easy to switch from one to the other or a combination of the two. So to me, this is like the best bet I have of like actually practicality for the next billion, and at the same time being friendly to users using the ecosystem in a decentralized way, in a way that they're actually still participating in all of the same playing fields. So summary, right? I think we can make applications that are mainstream friendly and decentralization friendly at the same time. And I think many tools for this already exist, and I think lots of other tools are under development. Some of these challenges are user experience, account abstraction challenges. Some of these challenges are layer 1, layer 2, blob, pre-confirmation scale challenges. Both of them are really important. And I think layer 2 teams can do a lot to help, both in being the best layer 2 that they can be and providing speed and scale, and at the same time making sure that they're aggressively progressing to stage 1 and stage 2, and actually preserving the L1 decentralization. And at the same time also like actually doing all of this excellent work of actually bringing in and appealing to all kinds of developers and users. So thank you guys all for your hard work, and look forward to this continuing for a long time.
Thank you. Vitalik, can we take some questions?
Mm-hmm.
Okay. So we can take some questions. We have about 5 minutes left, so we can take some questions. Please raise your hand, and then you can pick and select, Vitalik, if you. And then
Okay,
we'll have microphone. There's one behind you.
Hi. Thanks for sharing, Vitalik. Have you considered using more advanced erasure coding for things like historical expiry, state expiry, etc., on the storage side and access side of the data, as well as for the transmission of the data, whether it's for pre-conf or peer-to-peer network protocol networking?
Yeah, I mean, I think my view on that is like switching the erasure code is relatively low value compared to other things. And like we already have an erasure code that works very well. And I think there's a lot of just efficiency and convenience benefits from just using the exact same code across the stack, right? And so for things like state expiry, like history expiry, what I favor is basically just putting everything into blobs. And blobs already have a really nice, really clean and working implementation of like de facto erasure coding because it's they're all polynomials and they're a Reed-Solomon code. And you basically use the exact same infrastructure to do a sharded history storage as you use for data availability sampling. I think in the longer term, we will have to upgrade from KZG blobs anyway because like the current KZG-based setup is not quantum resistant. And so I think there is a longer-term opportunity to upgrade to something else. I mean, I think like re-looking at the erasure code is one of those things that's worth thinking about, though I think it's also worth like appreciating just like the simplicity and beauty and legibility of just using polynomial evaluation. So for me, like I think that's a discussion for I think like the 5-year roadmap. Like I think for now, blobs as we have them are the way to go.
Do we have any more questions? The back.
No.
Back.
Thank you. Talking about blobs, do you have in mind specific limits in terms of storage and in terms of bandwidth, specifically from the point of view of solo stakers that are now very vocal on Twitter on the minimum requirements? Okay, so let's look at the roadmap. Let's say long-term roadmap, full data availability sampling, 16 megabytes is a lot, right? So that gives the entire blockchain a bandwidth of 1.33 megabytes a second. And so if you have a node that wants to like fully store everything, then of course per year that's going to turn into 1.33 times 32 million. And so you're going to get about 40 terabytes per year, right? Which is like definitely doable for a hobbyist, but like you do have to put in resources into it, right? For a node that's just participating in this network with 2D data availability sampling, you would only have to download a fixed number of samples, right? So you should be able to download only 80 samples, and then each sample plus the proof would be like less than a kilobyte in size. And so if all of this is implemented correctly, the raw amount of information that you have to download would only be about 50 kilobytes a slot, right? So it's extremely possible for to do a very performant blockchain with huge amounts of data, but only impose a very small load on each individual participant. Now, that's obviously not like the status quo today, right? The status quo today is like if you increase the blob count, then that means that either like solar stakers have to process more data, or it means that we have to figure out some efficiency improvements on the peer-to-peer side, which I think actually might be possible, right? Because as I said, right, blobs are already natively erasure coded. Erasure coding is actually one of those strategies for optimizing peer-to-peer already. Maybe there's like something quick that can be figured out. But in the long term, I think it's like the sampling approach, if you do the math, actually is very data light on individual nodes. Even for upload, yes. I think, yeah, the statistic for like 50 to 80 kilobytes, that would be download and upload. I think, I mean, probably the closest thing to an exception would be like the block building process. But then for block building process, like two answers, right? One is that as a client, you could always not participate in block building. You can only do like inclusion list and attestation responsibilities. And the other answer is that you can do the like there are designs for distributed block building where you would not like it would be more than 50 kilobytes. You would have to like download and upload potentially a megabyte in a slot, which is like actually pretty comparable to at least the worst case of what you have to do today already.
Since no one has asked it yet, what are your thoughts on beam chain proposal?
Yeah, I mean, I think, the core ideas there, right, I think align a lot with ideas that I've been talking about all along, right? So I think the core ideas are all correct. I think the one thing that, like, I personally think we need to be careful about is, like, I don't think we should go too fast and too like reckless in reducing the slot time of the L1, right? Because like as Phil said in his presentation yesterday, for Ethereum to be decentralized, it needs to be geographically fair. And if we try to like hyper optimize Ethereum for as short slot times as possible, then stakers in Latin America, Southeast Asia, Africa will be disadvantaged compared to stakers that are very close to and very well connected to New York. And like that's a future that we don't want, right? And like there is already concerns among those stakers even today. And so I think we do need to like watch that very carefully, right? But I mean, I'm definitely open to the possibility that there's lots of just very unclaimed peer-to-peer optimizations that could be improved a lot to help stakers in those regions, right? So, but I mean, other than that, like I think all of the ideas make sense. I think the one thing that's really important to keep in mind is that like there is this trade-off of doing those ideas in an all-at-once fashion versus doing them in a more incremental fashion. And there's like actually a lot of debate among core developers about which approach is better, right? Because I think the benefit of this like all-at-once approach is that it's very good at bringing in new people into the consensus research process, right? And I mean, even I think a lot of people here would be, if you show interest in participating in a beam chain redesign, even if you haven't done beacon chain stuff before, like you'd be very welcome, right? But then the other side is that actually doing bigger changes can be risky. And so I personally expect we'll see some combination of both. And I also expect that, like as I've said before, right, like the roadmap time for completing the full thing and like creating this maximally ideal, platonic, beautiful Ethereum chain is 2029, but you're going to get lots of very, very important upgrades long before that, right? So this full data availability sampling roadmap, I think, if people put their mind to it, can be done in 2026. And like for earlier steps can be done even earlier. And then also, same thing for the right side of this. Single slot finality, I think, can potentially be done in a similar time frame. Potentially, like statelessness could be done. I would say it's like probably worth doing it a little bit later and focusing on single slot finality and EVM improvements and DAS first, right? But huge amounts of very important things that are needed to actually complete the underlying goal of like getting to 100,000 TPS in a way that's on chain and that respects decentralization and openness and permissionlessness. I think that can be done like much sooner than the full 2029 figure.
Do you want to take one last question? Okay, one last question.
Standards?
For interoperability with L2s, do we need standards? Yes, we absolutely do. And there's lots of groups working on those standards right now.
Perfect. Thank you very much, guys. Thank you, Vitalik.